amazed at the interest we got in this video, and I really appreciate the support and the comments and all the subscriptions, and I'll be glad to keep putting these things up as long as anybody's interested in them. We got a lot of little things today. I want to feature the 14-inch G&E shaper. We got a little job set up in that, and the drill press and the lathe. We got steam up, and we're gonna get going on this stuff. So stick with us. I have a job set up on the little shaper, so I'll show you a little bit about it. It's a early 1920s Gould Everhart 14-inch stroke, and I'll show you a little bit about the belt drive. I have to run a cross belt on it to get it to run in the right direction, and I'll show you a little bit about that later. The clutch setup is typical of how a machine would be set up on a line shaft. The pulley on the far right is called the loose pulley, and it just sits there and spins on the shaft. It's got a Babbitt lining in it, and it's an idler pulley. All the time the line shaft is running, that pulley is moving. When you want to operate the machine, you move this lever here, and it won't do it now because the line shaft is not running, but the shifter will slide the moving belt over onto the tight pulley, which is keyed to the shaft, and that starts the machine running. The other pulley should actually be a stepped pulley that matches the steps on the machine so that you can have different speeds, but I was not really in the mood to make one when I set this up, so I just have a single pulley there running down to the first step on the machine. Now when you set your work up in here, in order to get the stroke set right, you measure your piece so you know how much stroke you want, and leave about 3/4 of an inch on each end. And this particular machine, this particular job was leave about 12 inches. And if you manually move the ram back all the way, then you have this handy little scale here, and by operating this lever you can run the stroke in and out to where you want it, and then lock it here. Okay, so that sets up your stroke, and then in order to get the stroke positioned over the work the way you want it, you loosen this clamp on top of the ram, and by turning this lever you can center your stroke up where you want it. We want it a little bit beyond the end, and then tighten it again. This down here is the feed works. The only feed this machine has is crossways, and this bar here oscillates, and you can set the stroke here, and there's a ratchet mechanism kind of similar to a ratchet on a socket wrench, and this is the little pawl. When you have it set here with this flat part crossways, it pulls the pawl away, and it just sits there and rocks back and forth, and it doesn't feed anything. When you have it this way, it will ratchet that way every stroke, and when you have it this way, it'll feed back the other way. You can set the amount of feed. There's a little ramp over on this side, and this whole sleeve turns so that it actually picks the pawl up a little bit, and it only lets it drop down to feed either 1, 2, or 3 teeth at a time. So you have basically 5, 10, or 15 thousandths per stroke feed. And I've not experimented with it that much, but I think if you move this out to a further position, you can get it to feed more than that, like 20, 25 thousandths per stroke for very rough cuts. This is it says patented on it. This is a little thing that keeps you from tearing the machine up. It's a little friction setup in this link here, so that if it hits the end of its travel here, it won't break something. So you leave this set just a little bit loose so that it can move if you get in a jam with it. The down feed is strictly manual on this. It's got a little gauge and pointer here, and you'd be running slow and feed it down by hand if you were going to feed down the side of your work. Now it's possible to get the feed backwards on this. If you're feeding crossways this way, you want the feed to happen at the end of the stroke, at the end of the back stroke, and it will do that. You'll see when it's running. If you have it backwards, it will feed on the way back and drag the tool against the cut. So that's not good. You have to pay attention to that a little bit. My vise is not really authentic. That's a late model vise. Someday might be able to find something a little bit more period, but I really like that vise. On this side, you can take this cover off, and I'll take it off when it's running so you can see and get around on this side. In fact, I'll leave it off. Come on. Also, I should tell you about this adjustment right here. If you change your ratchet to feed the table from left to right, you have to move this pivot to the other. It pivots in the center of itself. It rocks back and forth. You have to move this pivot over onto this side of the center so that it will feed the table at the end of the back stroke. That's what that's for. This lever here elevates the table up and down, and of course this is to adjust your stroke. Time to get to work. if you can see, but that sliding block running up and down on the pivot, and the lever arm actually pivoted at the bottom. So because the sliding block is closer to the lower pivot arm on the return stroke, the shaper comes back faster than it goes forward. I don't know if you can see that, but the speed of return is about 25% faster. That's why it's really important to make sure you're running the shaper in the right direction. I mean, it'll work, but you've got to fast forward and a slow gig backwards. Got a little pipe threading job to do here. I don't know if you could see this real well. Reed Manufacturing, patented 1902. While the shaper's going on that cut, I got a boring job set up here in the drill press. I got to bore and ream this out to 1 inch, and I got a couple more holes to drill in it. It's on auto feed here. These drill presses had 4 different down feeds, 5, 7, 9, and 16 thousandths per revolution. Then you had 4 belt speeds, and also right now it's running with the back gear engaged. Get around on this side. This lever right here engages in this fork and stops this from turning, which allows the planetary gearing in there to gear it down quite a little. You can see the difference between the speed of the pulley and the speed of the shaft. And down here, you've got the same loose and tight pulley arrangement. The left belt is the drive belt, and it's on the tight pulley now. This one here is the idler. It's just along for the ride at this point. And this is the clutch that shifts it. And I'm in the second to the slowest speed with the back gear. And I got to run a cross belt on this in order to make the drill press turn the right way. Let's go over here and check on our progress with this. This is actually the second cut. I'm just trying to square this piece of old wrought iron up because I want to save it and make a couple of step blocks out of it for fixtures. This is a flange for a line shaft to couple two pieces together. It's 1 inch and 15/16, which is the size shaft that I use in the shop here. And this thing is just in there. I had about 30 tons on this and it couldn't move it. I heated it and played around with it, and I kind of like to save it. You can see it's got a couple of nails driven in on top of the key. So I'm going to put it in the lathe and bore most of it out. And I think if I get most of it bored out, I could take it out in pieces or maybe bore the whole thing out. I'm not exactly sure. Face up this, and I may have to sleeve it. I don't know. Let's see what the bore looks like when I get into it. So that's a little lathe project. Yeah, this is working a little bit better. That's at 5,000 speed with my high-speed steel tool bit and a little bit of cutting oil. And that side's done. Well, thanks for watching my video, second in the installment plan, and hope you enjoyed it. I want to thank you all again for the support and all of the comments and likes and encouragement that I've gotten on this channel, and I'll answer every question I can. And I had a lot of video here that I didn't have room for in this one, and we'll just put it in the next one. One thing is, I got a little repair on a Norton 750 motorcycle cylinder head we did in the shop. I've got a governor pulley here for the steam engine that I made a while back, and it's a little bit bigger than the one that's on it now. Let's speed the governor up, make it a little more sensitive, make it work a little bit better, and I got to pull a crankshaft out of the engine to do that, and some other things too. So thanks a lot, and hope to see you again.